Now the viscous force is not applicable only at the point when we are stirring a fluid placed in a container or beaker. No, actually viscous force is everywhere present whenever there is a motion of what fluid, even if the fluid is in tube form. Suppose there is a cylindrical tube in which there is a steady flow of this fluid. So what do you think, what type of layers will form in that tube motion? Actually, if the fluid is flowing in steady way due to under the pressure of some external pressure, the fluid is going to form cylindrical layers, and cylindrical layers will move coaxially along the axis of the tube like this. Okay, so see, what do you think, where will be the viscous force maximum and the minimum? The viscous force will be maximum when there is some stationary point in the tube, and that is at the surface of the tube, which is inside surface. So the liquid layer or the cylindrical layer of the fluid which is in contact with the wall of this tube will be having minimum velocity, whereas the cylindrical layer which is at the center of this cylindrical tube will be having maximum velocity. So if I'll just give you an idea of what would be the velocity thing, this would be the velocity vectors. It will keep on decreasing as we go from center towards the wall of the tube. This would be the length or magnitude of velocity of different layers. Now there was this scientist Poiseuille. So Poiseuille's formula was for the amount of liquid flowing through a tube or amount of fluid passing per unit second of a tube. This is what I am denoting it with V. This is what the volume of fluid flowing from this tube per unit second or in 1 second. So volume of fluid which is passing through this tube in the presence of external pressure is, according to Poiseuille's formula, is directly proportional to, first of all, the pressure difference between the ends of the tube, whatever pressure, because this fluid is moving in a laminar way because of the external pressure applied, right? So there must be some pressure difference between both the ends of the tube. So this volume of liquid per unit second is directly proportional to, first of all, pressure difference, and is also directly proportional to radius raised to power 4. This is the radius of this cylindrical tube. Now it is also proportional to, inversely proportional to, length of the tube, because more the length of the tube, more will be the chances of fluids getting into rest because of more extent of or more application of viscous force, right? Lastly, volume per unit second is also inversely proportional to viscosity. If I combine all these formula, all these factors, I'll get PR4 over L viscosity. So V is equal to, constant of proportionality here is pi by 8. So the formula becomes pi by 8 PR4 over L times viscosity. So this formula can also be derived using the dimensional analysis. This is what Poiseuille's formula is about, the volume of fluid flowing per unit second from a tubular form.